Hello, today we're going to be doing a presentation about plants and why we need plants. Now, plants are commonly overlooked in that when they're feeding cattle, you're not really looking at the plants that they're feeding the cattle, or if you eat chicken, you're not looking at the chicken feed. And, people see trees everywhere, but most people don't appreciate them. And they really are our saviors because without them, there would be no humans because we can't eat anything. We can't eat dirt, and we can't eat solid rock, and we can't eat pure minerals. But they're not just food, they're our friends. This PowerPoint will minimally explain how plants benefit us as humans, how photosynthesis works, and how roots have adapted to different soil conditions. Our plants filter the atmospheric pollutants. They do this by taking in CO2 and nitrogen from the atmosphere and exporting oxygen. They also don't really care as much about pollution within the atmosphere, and when they're taking in this CO2, they're also taking in certain types of pollutants and exporting pure oxygen. And in the process, they do hurt themselves because of the pollution, but they're basically sacrificing themselves to make our atmosphere more clean. They translate energy from the sun in that they take in sunlight, and again they're exporting oxygen, but they're also taking in that energy and storing it for themselves and to feed us and our livestock. They're also supporting vital ecosystem services such as, they're preventing erosion on the edges of any area where there's a river. They prevent erosion and keep the land where we need it. And they also are a host to many types of wildlife and bacteria that we need, and also certain types of beneficial insects. They utilize light, CO2, water, and minerals, and provide us with what we need. Photosynthesis is when a plant takes light, CO2, water, and nutrients, and then they take the light and they combine it with CO2, water, and trace amounts of minerals, and they export glucose into their own cells. And by doing this, they produce food for themselves. And then we can also eat that plant. The plant mass itself originates from photosynthesis. Photosynthesis is what makes the energy. It's what it doesn't. I shouldn't say it makes the energy. Rather, it translates the energy into plant mass. We can't simply eat the sun, and we can't eat minerals, but we can eat sunlight and minerals if they are accumulated through plant mass. Eventually, the plant mass is accumulated minerals, but it's mostly water. It doesn't need too much minerals, but it does need a lot of nitrogen, phosphorus, and potassium. Those are the three main minerals that a plant mass is made out of. And what you have with glucose is sugars. But mostly the plant is water. Without water, if you've ever seen a dried up plant, it's extremely thin, and it's not what you think a plant would look like without water, but they're very, very reliant on water for their mass. Now there's a couple of factors affecting the plant mass. Nutrient availability, pH level. Within soil, it should be around, now all soil is going to be acidic, but it should be around 7. And for hydroponic situations, you're looking at a pH level of about 6, which is acidic. And the pH level has a huge impact on the plant mass because if the pH level isn't right, the plant won't be able to take in its nutrients, and that has a huge impact on the plant mass. Elevated CO2 levels will allow the plant to grow bigger. Ventilation allows the plant to grow bigger because it gets fresh air with more CO2 and less stagnation. They don't like to be kept in an area with no ventilation because they don't get the airflow that they like. And the intensity of the light hitting the plant has a lot to do with it. If you've ever noticed, the plants at the bottom of a forest don't look very healthy. They're showing all kinds of deficiencies, and they just don't grow very big. It's the plants that, like the trees that get to the top, that get the really intense light, that really do well. You'll never see a huge tree on the underside of a bunch of smaller trees. And proper moisture levels within the soil have a lot to do with it as well. If there's no moisture, you're going to have something like a desert situation, where in the desert you don't see very many plants at all. I mean, you see ferns and cacti and whatnot, but as far as plant mass goes, you go to the tropical rainforest and you're going to see a heck of a lot more plant mass there, and the reason for that is because of the moisture levels, and also because of the nutrient levels within the soil. But in the desert, you don't have any moisture, or hardly any, rather, and it's going to affect the amount of plants that you see. Now, the sugars stored after photosynthesis are what we really eat. Now, you think of sugar as being really sweet, but really sugar is a broad term for many types of glucose and sucrose and other types of sugars that, to the plant, they're not really that sweet, but it's what the plant eats. Basically, they make their own food, and these sugars become the own plant's nutrition. Plants in general provide our livestock with food. If you've ever seen cattle grazing, they're taking that grass and they're turning it into flesh, which we love. I mean, I shouldn't say we, but many people love to eat, flesh of certain types of animals, and without plants that would be impossible. The plants are converting the sunlight into sugars, and these sugars are edible. Then we eat the plants and animals. Now on to houseplants. Houseplants, I'm sure a lot of you have houseplants, and I'm not sure if you've ever really taken a look at one, but I'd like to think of them as our friends because they're providing us with oxygen, and you keep them company and they'll keep you company. And they can yield a variety of herbs which are delicious, provide a healthy hobby because it's something to do with your time. You're taking care of plants. And you can also give some seeds a good life, because without you, they would not exist, and they need you. Plants grown in low CO2 conditions quickly become spindly. Now, the reason for that is because they're not getting enough food from the atmosphere, because they need to fix the carbon, and they're a carbon-based life form, and they get their carbon from the atmosphere. So without carbon dioxide, they're not going to yield fruit, they're not going to yield flowers, and they often die due to increased susceptibility to disease. Now, the roots are what the plant uses to search out for nutrients and also water, but they also provide fixation for the plant. Otherwise, how would it grow upwards? Because it would just topple over without the roots. But they can also be used to strangle out other plants' roots in competitive settings. They can also steal other plants' nutrients. Plants have evolved many different root types over millions of years. They've been evolving. Differing moisture conditions cause this. Like a cactus is going to have really long roots because it needs to search out water. But almost all roots share a purpose, and that is to bring moisture and nutrients to the plant. And most roots also require oxygen, which is commonly overlooked. They can't just get, if you have a plant sitting in just water, most of the time, unless it's an aquatic plant, it's gonna die, because the roots also require oxygen. They have to get a certain amount of ventilation to the roots as well, which is why compacted soils don't grow plants very well. They like to have airy soils. Now there's the taproot, which is a carrot, basically. I mean, it's not just a carrot, but that's the best example that I can think of. And it's a huge central root with many smaller hair roots extruding. This is common in dense rooting situations where you have a lot of plants packed close together, so it's advantageous for them to have just one big root going down with a couple of smaller ones, but mostly with a big root so that it can just get its plot of land taken care of and not have to worry about all these other plants that are surrounding it. Now the adventitious root is a different kind. It grows in all directions. It comes straight off the stem. It's very fibrous, and it's most importantly extremely prolific. By that I mean it'll grow wherever it can. It'll crack foundations. It'll crack sidewalks. It can go around other plants' roots. I mean, it'll do anything it can to find the nutrients and water that it needs. It can even come straight from the stem, which if you take a plant with a growing shoot or a growing stem, a lot of them you can cut the stem and plant it straight back into the ground, and it'll grow roots right out of that stem. And the reason for that is because it'll grow adventitious roots anywhere that the humidity level is over 90%. It can grow these roots. Even in the middle of the plant stem, if you were to put a saran wrap around the middle of the stem and get the humidity up, it would grow roots right out of the stem. Now the fibrous root comes off other roots. It becomes very, very thin. And the reason for this is because it wants to get maximum surface area for the amount of mass that it has. Now, fibrous roots are very light, but they have a lot of surface area, which means a lot of absorption for minerals and water. Now, in general, the bigger the root system, the more powerful the plant, and more roots means more water and nutrients. Super healthy roots should be bright white for herbs, and I'd say brown for a tree, but you know, it's gonna vary. But most plants, if you look at them, their roots are going to be bright white if they're healthy, if they're getting enough oxygen. If they don't get enough oxygen, they'll be browning and smell bad. But don't rip a plant out of the ground. It's not nice.